What is scientific method? The scientific method is a systematic process to obtain objective information and to test theories. Key features of science: objectivity, views based on observable phenomena that can be verified by measurements and not personal opinion or prejudices. It is based on empiricism. Empiricism, providing evidence by gaining information through direct observation rather than by reasoned argument or unfounded belief. Replicability, the ability for procedures and findings to be reproduced or repeated. Rational, based on reason and logic. Systematic, gathers information systematically and unbiased. We must be aware to separate common sense, beliefs, and pseudoscience when conducting scientific research. The scientific process: traditional views of scientific methods included induction and deduction. Induction is the development of general theories which can be used to explain data that has been observed, however it cannot make predictions about what might be found. Deduction is the development of general theories about observed data which can then give specific hypotheses that can be tested. It starts with a theory and looks for circumstances to confirm it. The scientific process: scientists use a dynamic, open-ended process to investigate questions. Here are the 5 steps. Define a question to investigate. As scientists conduct their research, they make observations and collect data. The observations and data often lead them to ask why something is the way it is. Scientists pursue answers to these questions in order to continue with their research. Once scientists have a good question to investigate, they begin to think of ways to answer it. Make predictions. Based on their research and observations, scientists will often come up with a hypothesis. A hypothesis is a possible answer to a question. It is based on their own observations, existing theories, and information they gather from other sources. Scientists use their hypothesis to make a prediction, a testable statement that describes what they think the outcome of an investigation will be. Gather data. Evidence is needed to test the prediction. There are several strategies for collecting evidence, or data. Scientists can gather their data by observing the natural world, performing an experiment in a laboratory, or by running a model. Scientists decide what strategy to use, often combining strategies. Then they plan a procedure and gather their data. They make sure the procedure can be repeated, so that other scientists can evaluate their endings. Analyze the data. Scientists organize their data in tables, graphs, or diagrams. If possible, they include relevant data from other sources. They look for patterns that show connections between important variables in the hypothesis they are testing. Draw conclusions. Based on whether or not their prediction came true, scientists can then decide whether the evidence clearly supports or does not support the hypothesis. If the results are not clear, they must rethink their procedure. If the results are clear, scientists write up their endings and results to share with others. The conclusions they draw usually lead to new questions to pursue. Criticism on scientific approach: you cannot study people in the same way as physical phenomena. It's usually studied in a lab, which is an unnatural condition which could provoke demand characteristics. The scientific approach emphasizes control, so tries to study one variable in isolation, but how can this really be applied to psychology, which studies people? By emphasizing control, it tends to treat people as passive participants. So information gained is likely to be superficial. Critics believe the notion of objectivity in science is a myth, as past experiences, beliefs, and ideas make it impossible to be truly objective.